So there's sort of a selection of rules of inference, and they, you know, if you look in a logic book, sometimes they often, there's more than this, but they often seem more somewhat arbitrary, and it's, you know, if you look at that, you'd hardly say there's any sort of pattern or anything like that. It's almost like a random selection. But actually, what it turns out is they're all special cases of the same rule, although that wasn't discovered till recently. So now what I'm going to do, I started last time, but I'll do it again, is when I'm going to put these in I guess I mentioned, in clausal form. I'll do everything in terms of implication. So we know how to do that. We know how to do disjunction as implications and negation, and that's about it. You can't do everything as implications. Conjunction is, there's no way it's a single implication. That's why we don't have conjunction rules. But let's try these. So the first one looks like this. So the important thing is everything becomes an implication. In fact, not just any old implication, it's an implication between variables, which is known as a clause. So this becomes so I'm being quite picky, because if you want A on its own to be a clause, you have to make it turn into implications. So that's the first one. The second one, now not B, we know is you put B on the other side of the arrow. And not A, similarly. Now A or B is just arrow AB. Now of course this I'm using the extended implication, takes a little bit of getting used to. You always remember that everything on the right hand side is implicitly ORed together. So if there's only stuff on the right hand side, that's ORed together. That's A or B, not A is and this one here, well this one here is already, I'll copy it again for the camera, but this one is already in clausal form. So A implies B, B implies C. Then there's the so-called law of contradiction that says if we have A, and if we have A not A, we get, now, what's falsity in clausal form? The empty clause, yeah, very important. And then we'll do, sometimes this is called reasoning by cases, and, well, that's not quite in clausal form. It says A implies B. Now, here we have, here's the one, we have not A implies B. Now, the thing is, this is not a clause, because a clause is an implication between variables. You can't have any other logical connectors in a clause. So you can't even have a not in a clause. Now, there's actually an easy way to turn this into a clause. How do we turn this into? All right, Nathan.
Okay, you just move the A to the right.
That's
Right
right.
of the arrow.
Now, there are rules like this. We'll learn them in a bit. But that's one thing you can do. If you have a negated thing on one side, you can move it to the other side and drop the negation. Very simple to do. So the A implies B, not A implies B, becomes A implies B, arrow A, B, and what you get at the bottom is arrow B. Yeah, if you look at the bottom, it's really obvious in this one. Probably this is the one that makes it clearest. Here you have A on opposite sides of the arrow, and the A's have the effect of canceling each other out. So clear, very obvious that happened there. But look what's happening here. It's actually the same thing. There's A on opposite sides of the arrow. So once again, the A's disappear. You get, and when they disappear, you get the B. Now, if you look at this one here, here it's the B that appear on opposite sides of the arrow. They sort of, like matter and antimatter, annihilate each other. You can see it again up here. There's an A on the left side and the right side, and then it cancels it. It's a sort of a cancellation. It's probably the clearest here. That here you have a B on the right and here you have a B on the left. So they annihilate each other. But what's happens is that the A from the left side goes through to here, and that the C from the right side goes through to here. So in fact, these are all special cases of a general rule called the resolution rule. It's a way of combining two clauses into one clause. And what you look for, it's very general. It's really easy to apply resolution. What happens is you need the same variable appearing on opposite sides of the two clauses you're combining. So here's a case of these two clauses, the rule is enabled here because the variable h appears on the right-hand side here and on the left-hand side here. So it's just one variable, and all you do is throw away that one variable so it sort of cancels itself out, and then merge the two cleaned up clauses. So you throw the left-hand sides together. And that's the resolution rule. Now, to write it out in its most general form is a little tedious, but I suppose I better do it once. So here it is written properly. You have one arbitrary clause, and actually it'll work for, it doesn't have to be restricted to clauses, but it's usually only clauses. You have a bunch of A's and an X, implying a bunch of B's, a bunch of C's, implying a bunch of D's and an X. And what you do is you remove the X from both these clauses and then just throw their left-hand sides together and throw their right-hand sides together. And that's the resolution rule. And the crucial thing here is that these are arbitrary sequences, including empty sequences. And what I mean is that N and M and J and K are greater than or possibly equal to 0. Now, I should say something about notation. If you look, for example, if you look at Wikipedia, you won't find it in this form. You will find the resolution rule, but and in fact I did it just before I came here. And it's sort of in an obscure form. What they talk about is literals and complements and so on. What happens is that in standard notation, you don't use this, what's called a sequent notation. What you'll write is that for this clause here, you write it as A1, not A1, or not A2, or blah, 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 or not AN, or not X, or B1, or B2, or BM. So for, I'm not going to write the whole thing out. So you write this way, and the thing is, in the other one, you're going to have X here, and the idea is they cross, then you throw these others out. So that's the standard notation. It's a real headache to do right, and part of the reason it's a headache is there isn't, standard notation doesn't actually cover the empty clause, because just by right, since OR is an infix operator, there's an assumption that there's at least a couple of clauses, at least a couple of formulas here, and there's no real notation for the empty clause in standard notation. Well, we know the empty clause is false, so you can just use false, but false isn't of this form.